if we have a straight conductor, then there is a loop over here, then again a straight part of the conductor. Suppose the current is like this. The current is in clockwise sense here. The question is, what is the magnetic field at the center? If the same current passes through in the straight part of the conductor, this point is non-contact point. That means the point is not, this point is not connected to this straight conductor, non-contacting point. This point is not the point on the loop and the point on the straight conductor are not in contact, just little above it. Or you can think that this goes like that. So what is the magnetic field at the center of the, so what is to find? So I is the current, R is the radius, R is the radius. So you are supposed to find magnetic field center of the circular coil. Now we'll have the contribution from both the straight part of the conductor, that will also contribute to this point, and because of the circular coil also there will be contribution. So the contribution will be from both, because the straight part of the conductor and because of the circular coil. So magnetic field at the center, so this point is O, is due to the magnetic field due to the coil plus magnetic field due to the straight conductor. Magnetic field due to the coil is mu naught upon 4 pi 2 pi I divided by R, and it is like this. So up, okay, here it is down clockwise, here I have shown anti-clockwise, no problem. If it is anti-clockwise, this is off, and then because of the straight part of the conductor, then also is off. So in this case it will be added. For this diagram it will be subtracted. Okay, I'll change the direction for you if you want. Okay, so this is the direction of okay, that was same, I like that only. Anyway, the current direction is here clockwise according to the question. It's clockwise like that. So if it is clockwise, then it is downward. So here the because of the circular coil, the magnetic field at the center will be into the plane of the paper, and due to straight part of the conductor, if you hold the conductor like this, the current is in this direction. If you hold it, the magnetic field will be up in this direction and down the other side. So it will up in this side. So for a conductor, this is up and this is downside for the magnetic field. So here you can see that there is a change in the direction. That is because the coil is into and because of the straight conductor it is upward. So subtract it. So we will have subtraction. Anyone I can call positive, anyone I can call negative. Suppose upward is positive, so this is positive. So therefore this will be negative. In terms of vector, this is negative. Okay, so I write minus. So plus, due to straight conductor it is mu 0.4 pi 2I by R. Why R? Because that point is the center of the coil, and from this the distance it will be equal to R. So if you solve it, then B at the center is mu naught upon 4 pi. I will take common. So therefore it is 2I by R minus 2 pi I by R. Then mu naught upon 4 pi, 2I by R is common. So 1 minus pi. 1 minus pi. And this is the answer to this question. If it is in this coil, if it is anti-clockwise current, then it will be dot here, and for this also it will be dot here. So then in that case it will be plus. So if for this situation, B at the center will be because in this case both the contribution will be upward, so add up. Earlier it was 1 up 1 down, so it is positive and negative, so there is minus sign here. Okay, thank you.